Okay, question 25. We've got Ollie throwing stones about. Dangerous practice. Hopefully there's nobody about. So the first thing I do with a question like this, almost always, is to draw a little diagram. So here's the sea. Here's my cliff. And at the top of the cliff, here's Ollie throwing the stone. The stone goes up almost vertically and then comes down and lands in the sea. So the cliff then is 20 meters high, and we're throwing from this point here, so I'm going to treat that as my origin, and I'm going to take the upward direction as the positive direction. I don't have to, but it seems sensible to do that. That's the start of the motion. Now, it's clearly a question relating to constant acceleration, so we can use the constant acceleration formulae, the SUVAT equations. So S, U, V, A, and T. So my U, my initial velocity in the upward direction, is 15. I'm not interested in the final velocity. My acceleration, because I'm taking the upward direction as the positive direction, acceleration due to gravity is in the downward direction, so I use minus 9.8 for acceleration, and T is what I'm looking for. Let's have a think about S though. S is displacement, remember, and it's displacement from the initial position, from the starting position. Now, if we're 30 meters above the sea level, then the displacement at this point, although that's 30 meters, the displacement from our starting point is only 10 meters, and it's 10 in the positive direction. So S is 10. The formula then I need to use is S equals UT plus a half AT squared. 10 equals 15T plus a half times minus 9.8 T squared. Then if you pop that all into your calculator to solve the equation, you should get two values of T. T equals 0.98 and 2.08, both in seconds. So that's the point there, 0.98 on the way up, and then on the way down, 2.08 seconds. So the stone is more than 30 meters above the sea between those two times. So if we take the difference between those, 2.08 minus 0.98, then the stone is above 30 meters above the sea for a total of 1.1 seconds. So how did you get on with that question? I hope you got the same answer. I hope I haven't made a mistake again. Anyhow, well done if you got the right answer. We'll move on now to the next question.